Hi friends, I'm Arasi. Welcome to Groovy Mathematics. In our past video, we were discussing about the base division of the bases where the divisor will be below the bases. The bases we discussed for 10 and 100, isn't it? Yes. And today we are going to discuss about the uh, numbers which are below the base, that is the divisor which are below the base, but the bases are higher, like 1000 and more. Can we go on? Yes, please come on. The first problem is 1234 divided by 888. Dividing a number by 888 and so on would be a little bit tougher task, isn't it? Yes, but using this base division method, we would be able to solve it very easily and within few seconds. Can we try those things? Yes, please, come on. 888, it is closer to which base? 888 is closer to the base 1000. 888 is closer to the base 1000, so I consider my base as the 1000. Then I'll just take my divisor and then followed by my dividend. Okay, my dividend is 1234 and my divisor is 880. First, what I have to do is I have to find the number of remainder digits. How many remainder digits is present in this? The base has 3 zeros. The base has 3 zeros. So my remainder, I have to split for my remainder. I have to split it for my remainder. It will be of 3 places. Okay. It will be of how many places? It will be of 3 places. So I'll be splitting the digits from the last. So I'll consider this 1, 2 and 3 and I'll split it here. So my remainder places will be having of here it will be having 2, 3 and 4 in the dividend place. Okay, then what I have to do, I have to find the Nikhilam of my divisor. What is Nikhilam? Nikhilam is all from 9 and last from 10, isn't it? Yes, we are going to apply that sutra to my divisor and I'm going to find the Nikhilam of my divisor. Applying that all from 9 and the last digit which is 8 here, that around by 10, I'll be getting the Nikhilam as 112. 9 minus 8 is 1, 9 minus 8 is 1 and 10 minus 8 is 2. So it's 112. Next, what I have to do? In base division, whatever may be the digit, whatever may be the number, don't worry about it. The first step for your answer of the quotient will be just bringing down the first digit of the dividend down directly to the quotient. So here my first digit is 1. So I'll bring that directly down. So my quotient first digit is 1. I have got the quotient here. And here the quotient is only one digit, isn't it? Yes, it's splitted here. So I'll be getting my next will be my remainder digit. So I'll be going for only one multiplication here, and for my remainder digit I can go for the addition, isn't it? Yes, I'm going to multiply this quotient digit, the first digit of my quotient which I have got now, with this Nikhilam number. Nikhilam number will not be considered, we will not be considering it as 112, but we will be taking it as individual digits. We will be consider one as an individual digit and other one as an individual digit and the last two as an individual digit, and we won't combine it. Okay, don't forget it. Okay, so multiplying this 1 with 1, 1 and 2, what I'll be getting? I have to go for the next thing. I have to take these digits and put it in the next succeeding places of the uh, dividend, isn't it? As below it, I'll take it. So multiplying 1 with 1 will give me 1, and similarly I'll multiplying 1 with 1 will give me 1, which I take to the next dividend place, and 1 into 2 will give me 2. I'll take it to the next dividend place. Now what I have to do, I have to add this, that is the 2 and 1. Adding 2 and 1, I'll be getting 3. Okay, next step what I have to do, I have to multiply it here? No, Only in the quotient places we have to multiply the digits. And here we have come for the reminder. We needn't multiply it. We have to just add it. Another thing you can also consider, I have taken till the last digit, have got the number. So only addition is enough. I needn't go for the multiplication procedure anymore. So, okay. So next digit, if I add it, 3 plus 1 will give me a 4, and 4 plus 2 will give me 6. This implies my quotient is equal to 1 and my remainder is equal to 346. Is it very easy? Yes, if you practice it, you can solve it much faster than this. Okay, come on, let's go for the next problem. Next problem is 10,102 divided by 7,989. Okay, 7,989. Somewhat a complicated number, isn't it? Yes, but we can solve it very easily. Come on. What will be the base for this number? The base for this number is 10,000, because 7,989 is closer to the 10,000. So I consider my base as the 10,000. And first what I have to do, I have to take the divisor directly. Then I'll go for the dividend. Then I have to find the number of digits for my remainder place, isn't it? Yes. So number of digits for my remainder place, my base corresponds to 40. My base has 40. So the number of digits in the remainder digits correspond to the number of zeros in the base. So my digits, like count from the end, the 4 digits, 1, 2, 3, 4. So I'll be splitting the digits here. I'll be splitting the last 4 digit which corresponds to the remainder place, and the starting place before the part splitted part, it corresponds to the quotient. The part after the splitted part, it is the remainder. It will give us the remainder. Okay, next what I have to do? I have to find the Nikhilam of my divisor, isn't it? What is the Nikhilam? Nikhilam is all from 9 and last from 10, isn't it? Yes. To find the Nikhilam of my remainder, what I have, divisor, what I have to do? I am going to apply all from 9 for all the digits and the 10 for the last digit. So applying the sutra, I'll be getting 2011. I'll be getting 2011. Okay. Now, what I have to do to get the answer? First step, initial step, whatever may be the number in base division, the first step is we have to bring the first digit directly down. Bringing the first digit directly down will give me a 1. I'll bring this 1 directly down. Yes, okay. Next, what I have to do? This will correspond to the first digit of my quotient. Now what I have to do is I have to multiply this quotient digit with my Nikhilam number. And don't forget that Nikhilam number, we will not combine the digits there and form it as a 2011, but we will be subtracting digits and we will be considering each and every digit individually. So it will be considered as 2011 individually and not as 2011. Okay, is it clear? Okay, now what I have to do? I have to multiply my first digit of the quotient with the Nikhilam number, and I have to put it in the succeeding dividend places. I have to take it to the succeeding dividend places. So multiplying 1 with 2 will give me a 2, which I take to the next dividend place, and multiplying 1 with 0 will give me a 0, which I take to the next succeeding place. Multiplying 1 with 1 will give me a 1, which I take to the next succeeding place, and multiplying 1 with 1 also give me 1, which I take to the next succeeding place. Okay, now what I have to do? My quotient part is completed. Now I am coming for my remainder part. So what I can do is I can directly go for the addition of the digits. I needn't worry about the multiplication place or a number of digits or anything. I needn't worry. I can just directly go for the addition of the digit as I am only in the remainder part. So 0 plus 2 will give me a 2, and 1 plus 0 will give me a 1. 0 plus 1 is 1, and 2 plus 1 is equal to 3. And this is the remainder part. While giving the answer, we will combine the numbers back to a common number, the digits back to a common number, and we will not be considering the digits separately. So my quotient here is 1 and my remainder is 2113. Okay, is it clear? Okay, come on, let's go for the next problem. Next problem is, yeah, somewhat a bigger number. It is 10,30,007 divided by 89,987. 10,30,007 divided by 89,987. What a bigger number, isn't it? Yes. How to solve it? Just solving this number by regular division will be a much cumbersome process, isn't it? Yes, it would be a very tricky and very tough procedure, isn't it? I have to first multiply this divisor. I have to find the multiple of the divisor. Then I have to check it with my dividend, and then I have to subtract it. I have to get the number. Then again I have to check with the multiple. Oh God, the process will be a very lengthy process. But here, are we going to do so? No, we are just going to take the base and we are going to find the complement of it and we are going to continue with the procedure. Okay, so 89,987. It will be closer to which base? It will be closer to the base 1 lakh. So my base for this problem is 1 lakh. Okay, next what I have to do? I'll be taking the divisor. It is 89987 and my dividend 1030007. Okay. Next step what I have to do? First I have to split my quotient part and my remainder part, isn't it? To get the remainder places, the number of zeros in the base is considered. Here I am having 5 zeros, so the number of digits to be splitted for the remainder should correspond to the number of zeros in the base. So it's 5. So 1, 2, 3, 4, 5. It has to be counted from the end, and I will be splitting it into the quotient part and my remainder part separately. I have splitted it. Okay. Next what I have to do? I have to find the Nikhilam of my divisor. What is Nikhilam? Nikhilam is all from 9 and last from 10, isn't it? Yes. Finding the Nikhilam of my divisor will give me last digit alone by 10 and the other digits by 9. So I'll be getting 9 minus 8 is 1, 9 minus 9, 0, 9 minus 9, 0, 9 minus 8, 1, and 10 minus 7 is 3. So my Nikhilam number is 10013. Okay, next what I have to do? I have got the Nikhilam, I have splitted my quotient part and the remainder part. Next I have to go for the solution, isn't it? For solving first place, what I have to do? I'll be bringing down my first digit of my dividend, whatever may be the number. Don't worry about it, just bring down the first digit to the quotient. Okay, it will become the first digit of my quotient also. So bringing down the first digit of the dividend, it is 1. So first digit of my answer is 1. Next what I have to do? I have to multiply this quotient, the first digit of the quotient, with the Nikhilam number. Each digit individually. I have to consider each and every digit individually and not as the whole number as 10,013. Okay, it is a very important thing in the base division. Each and every digit should be considered separately. Okay, now I'll multiply this with 10013. Okay, I'm multiplying 1 into 0. Where I have to put those values? In the corresponding dividend digits. Okay, in the corresponding dividend digits, succeeding dividend digits, I have to place this multiplied value. Okay, so 1 into 1 will give me 1. I'll take to the next succeeding digit and then 1 into 0 is 0. Next 1 into 0 is 0 to the next succeeding place and 1 into 1 to the very next succeeding place and 1 into 3 to the next succeeding place. Okay. Next step what I have to do? Yet I am only in the quotient part. So what I am doing? I'll add this place, next digit place. I'll add those values there. Here I am having 0 and 1. So I'll add this 0 and 1. Next what I have to do? I'll be getting the answer as 1. It will be the next. The added answer will be taken as the next digit of my quotient. Now what I have to do? I have to multiply this digit, the very next digit alone, and not the whole number as the 11. Only the very next digit alone. This digit alone has to be multiplied with the digit, Nikhilam number. Okay. And it has to be placed to the next succeeding places of the dividend. Okay. It has to be taken to the next succeeding places of the dividend. Okay, it's in the quotient. You may ask me in the previous sums we didn't do so, but in this sum why are we doing? Because it is in the quotient. We are using the quotient value here. We are, in those problems we had only one digit in the quotient. Whatever may be the number of digits, we may have even a 10-digit quotient number. Then too, we have to follow the same procedure. We have to add it and we'll be getting the quotient, and then we have to multiply the quotient with the Nikhilam number and we have to take the values to the remainder part succeedingly. Okay. In the remainder part, we need not go for the multiplication. We can directly add and give the answer. Okay. So 1 into 1 will give me 1, which I take to the next succeeding position. Then 1 into 0 is 0. Then 1 into 0 is 0. 1 into 1 is 1. And 1 into 3 is 3. Okay, now I have got it. What I have to do now? Now I have to add it. Just addition of all the places. Okay, all the digits in each and every places. Okay, and I'm not going for multiplication as I'm in the remainder part. Just remind it. Okay. Oh, okay. 3 plus 0 plus 1 will give me a 4. 0 plus 0 plus 0 is 0. And 0 plus 1 plus 0 is 1. And 0 plus 3 plus 1 is 4. And 7 plus 3 is 10. Okay. Pause for a minute. Just see there. I have got a 10 here in my remainder part. Do you remember? In our past video, we discussed some problems of such kind. Yes, if we have more than one digit, either in the quotient part or in the remainder part, then what we have to do is we have to carry over those digits to the previous number, isn't it? Yes. So I'll be splitting this digit 0 into two parts, that is 0 and 1, and I'll carry over this 1 to this 4, and so I'll be getting my remainder as 40,150. Okay, we have to carry it. Now check it for a reminder. It's below the divisor, so this is the reminder. Now my quotient here for this problem is 11 and my reminder is 40,150. Okay, is it simpler? Yes. If you practice any number, let the dividend be of any number of digits, let it be of any numbers, and your divisor should be closer to the base and it should be below the base, and just practice any number of problem. If you practice so, you will be able to solve these problems within 5 to 10 seconds. Okay. Our bigger number divisor too within 5 to 10 seconds will be a enjoyable and funny moment, isn't it? As practice it. And if you have any doubt with it, please share it in the comment box or just mail me. Okay. And if you need to practice more problems of such kind which are much interesting, just subscribe my channel and share it with your friends too. Okay, bye.